My guess is that we'll have a quiz tomorrow. Right? Like calculating slopes, things like that. Maybe some solving for y. Okay, we're starting now. Okay. The one change to this slide since I made it is that there is no day 2. There's only day 1. Okay, Julian, turn around. Julian, turn around. Turn around, sit forward in your seat, okay? So we've been using the standard form so far, right? AX plus BY equals C. You're supposed to know what the standard form of a line is. And with the standard form, we saw it's easy to graph by finding the intercepts. How do you find the intercepts when you got a standard form equation? You substitute the other variable as 0. And because in that form, if the form that it is, basically you cover up one term, solve what's left, cover up the other term, solve what's left. That gives you 2 points. And how many points do you need to draw the line? 2 points. So that's all you needed. So that's great, right? But that's not the function form, because when something's in function form, it's solved for y. You know, look at your calculator. Calculator's got a button on the top left which has got y equals. That's for functions, right? That's what our calculator is for us to graph functions. And AX plus BY equals C, we don't actually have a way to put that in the calculator. If we want to put it in the calculator, we got to solve for y. That's one of the reasons why we've practiced that a little bit extra, more than just what the book called for. So when you solve a linear equation for y and simplify it, right? You shouldn't have any like parentheses or like terms left. That is called slope-intercept form. And my guess is you've had this before, right? But still, you know, if Mr. Pacer I asked you, said, what's the equation for slope? You're going to say, y equals mx plus b? No. That's slope-intercept form of a line, right? The equation for slope is y2 minus y1 over x2 minus x1. We confuse these things. Okay, so the y equals mx plus b. M, as we just saw in the homework, that's the slope, right? B is the y-intercept. That's why it's called slope-intercept form of a line. Right? If you have an equation which is not solved for y, you should solve it for y. It says you have it in that form. Then you can graph it with the calculator. There's so much you can do once equations are solved for y. Okay. So identify the slope and the y-intercept. Y equals 3x plus 4. What's the slope? Okay. So remember, compare it with the y equals mx plus b. The m is whatever the coefficient of x is. In this case, the coefficient of x is 3, so m equals 3. And the y-intercept is 4. Okay, what does that mean again? Y-intercept? What is it on the graph? Yeah, where it crosses the y-axis. Okay, so at 4, right, at the point 0, 4, this line crosses the y-axis. Okay, identify the slope and the y-intercept. What is the slope? Say again. You got to solve for y, right? Before you do any of these things, you got to have it in slope-intercept form before you can read off the coefficient of x as the slope. So how do I solve this one for y? Subtract 3x. Or, like I was trying to get you to do before, right? If it's positive on the left, what's it going to be on the right? So it's y equals negative 3x plus 2. So now, what is the slope? Negative 3, so whatever's in front, okay, and b is 2. Okay, so you do this one. M equals B equals. Done? How about Evan? What's the slope? What's the slope? I'm still asking, what's the slope? There you go. Slope is 5. Okay, and who's how about Lily? What's the y-intercept? -3. Done. Okay, you try. This one you're going to have to solve for y first. Okay, how many? What's the slope?
1.
How many said -1? Nobody? Not? So first you got to solve for y. How do I solve that for y? Subtract 3x from both sides. Again, if the 3x is positive on the left, what is it going to be on the right? So it's -3y equals -3x. And I saw more than one say -12. But what's the sign of the 12 here?
There's no sign, so just
It's positive, so don't change the sign. Okay, then what? You divide every term by -3, right? -3. So that gives us y equals -3 over -3 is +1, which we usually don't write, right? And then -12 over -3 is 4. Okay, what is the m? 1, and the b is -4. Piece of cake. Okay, one more. Identify the slope and the y-intercept. First, you got to solve for y. Okay, what did we get for the slope? Ty, what'd you get for the slope?
Me?
Yeah,
I don't know. I think I got it wrong.
just say it. Jackie's going to steal your glory. Come on, Jackie. -1/4 sounds right to me.
I would have got it wrong.
How about a y-intercept? How about Matt? What's the y-intercept? No, come on. You were not doing anything like you're done.
I got it.
What'd you get? 3/2, right? So remember, one way or the other, you're isolating the y on the left. So you subtract x from both sides, or you just move the x, right? If it's positive on the left, it should be positive on the left, it should be negative on the right. 4y equals -x plus 6, right? You can't put those together because they're not like terms. Okay, then divide everything by 4. Divide 4, divide 4, divide 4. Okay, so y equals, and you could write this like -x over 4 plus 6, sorry, we should simplify that. 3/2. Or you could write it like this. Y equals -1/4 x plus 3/2. They're the same thing, right? So the m then, come on. M is that number, and it does not include the x. If you include the x, you're going to get points off, because the slope is only the number in front of the x. And the b is that number, 3/2. Too easy. Okay, now that we know how to pick out the slope and the y-intercept, we should graph lines that are in slope-intercept form. Right? The first step is going to be plot the y-intercept, and then second is use the slope to find the second point, and then we'll connect those points with an infinite line. If it's not in slope-intercept form, then you have to solve for y first. Right? That's always the thing. Solve for y first. Okay, how about this one? Can I graph it right away?
No.
What do I have to do? Okay, if that x is a positive on the left, then it's to be negative on the right. Okay, negative 2x plus 3. Okay, so what is the first step, as I just said? Remember, first step. Plot the b, right? So where am I going to put that plus 3? Does it go here? No. That would make it the x-intercept. It's the y-intercept, so that goes here. Okay, now what is the slope? Okay, so when you don't see a fraction, you need to put that over 1. Because we need to have directions that tell us the rise and the run. Right? When it just says negative 2, you may not understand. It does have a left and right component to it. So the negative 2 is telling you to do what? Negative 2 in the numerator means down. And a plus 1 in the denominator means right. So that means from that point, starting at the y-intercept, right? It's not like the point negative 2, 1. Or it's not like starting at the origin and going down 2 and right 1. It means starting at the y-intercept, go down 2 and right 1, and then make another point. Okay, and now there's the 2 points. That's all you need to graph the line, so sketch in a line. Okay. So you try, graph that one. Okay, so first solve for y. Okay, the m is what? 2/3, right? And the b is negative 4. So what is this 2/3? The 2 in the numerator is telling you to go up 2, and the 3 in the denominator means right. Okay, so first you graph the y-intercept, then you go up 2, right 3. There's your second point. Connect them with a line.
Can you do the third point too?
Sure. If you want to keep going, like up 2, right 3, it'll still be on the same line. Okay. 13. Last thing. This was the thing I just added. You know, what do you know about parallel lines? Yeah. They never touch, right? If you graph parallel lines, they never touch. So if I'm looking at them, it's not very good, but if they don't touch here, right? If they're not touching here and they have the same slope, that means they go up and over exactly the same. Then they never will touch. So they're not touching in one place, they're not going to touch anywhere. So what do parallel lines have in common? They have the same slope. So if we want to compare lines, you know, here's 3 lines. 2 of them are parallel. How are you going to determine which 2 are parallel? Yeah, I mean, I think somebody said graph. You could graph if you're really accurate the way you graph, or you could just calculate it, right? Use the formula we did last time. So let me do that. So in this first one, the m is going to be 0 minus negative 1 over 2 minus negative 1, which is positive 1 over 3. Right. The second one will be negative 1 minus negative 3 over 5 minus 0, which is going to be negative 1 plus 3 is 2, and over 5. So those are definitely not parallel because they don't have the same slope. And then the last, negative 3 minus negative 5 divided by 4 minus negative 2. Right? Negative 3 minus negative 5 is like negative 3 plus 5, which is positive 2. And 4 minus negative 2 is like 4 plus 2 is 6. Now 2 over 6 can be simplified, right? to 1/3, right? So which two are the parallel lines? Parallel lines because they have the same slope, right? All right, so you try one.
What?
Okay, what was the slope of line 1? Line A. The first one should have had a slope of 1/2. What about the second line? 2. And what about the third line? 1/2. So which two are parallel? Right? Since these two are the same slope, A and C are parallel. Parallel. How? 4 minus 2 is 2. 3 minus -1 is 4.
Oh, I did it. I did it, yeah.
Okay. So that's the homework.
Actually, I only just one.
Yeah, hurry, come back. Gotta wait. Sure. Sure, if you want to take somebody, now's a good time. You're doing that stuff? Yeah. He needs it, but he just went to the restroom. So Katie and Zach would be good. Or maybe even Samantha.